So we've been talking about atoms. Let's talk about ions. Ions are related to atoms. Atoms can gain or lose electrons. We said that an atom has an equal number of protons and electrons. The number of protons stays the same because that's like the soul of the atom. That identifies who the atom is, which element it is. And so that does not change. The number of protons doesn't change. But the number of electrons can change. Remember we talked about how the protons and neutrons were in the nucleus, in the center of the atom? So here we're looking at neutral magnesium, and we've got 12 protons in the middle because magnesium is element number 12 in the periodic table. Find it over there in the upper left corner. So it has 12 protons and it has 12 electrons. The electrons are out around the outside of the atom, and I kind of think of the protons as being like the soul or the personality of the atom, and the electrons being more like the clothing, the outward appearance of the atom. And so you can change your clothes, you can change your hair, you can color your hair, you can put on makeup, you can make yourself look different, but you're still the same person, right? So an atom can look different by losing or gaining electrons, and yet it is still that element, okay? So magnesium can lose 2 electrons. When it only has 10 electrons, it still has 12 protons, and now it has a +2 charge. But it is still magnesium, it's just not an ion. I mean, it's not an atom, it is an ion. So we lose 2 electrons. Those 2 electrons have to go somewhere, they don't just disappear. You take your sweatshirt off, it goes somewhere, right? Contrary to, my kids would like me to believe that their sweatshirts at school just disappear, but they don't. Sometimes they end up in the lost and found and we get them back later, but they're going to be somewhere. So that's how a cation can form. Metals tend to form cations by losing 1 or more electrons, and they form positive ions called cations, and that's a word you need to know. A cation is a positive ion. If you like cats, if you have positive feelings for cats, then that might help you remember that cations are positive. And if you don't like cats, maybe you can think that Mrs. K likes cats. Mrs. K has positive feelings for cats, except when they pee on my shirt in the laundry room, which that cat peed on, 2 different curtains and a shirt over the weekend. I think she's mad about something. Anyway, so cations, they're going to have a slightly, we need names for cations, and for these metal cations, the name is generally the same as the name of the parent atom. So this is a magnesium atom with 12 protons, 12 electrons. This is a magnesium ion with 12 protons still, but only 10 electrons. Any questions? Nonmetals tend to gain 1 or more electrons and form negative ions. Nonmetals make negative ions. Okay? Negative ions are called anions. And these are pronounced cation and anion, not cation and anion. I always get one person say that, so I'm just going to tell you so you can avoid embarrassing yourself. Cation, anion. So anions are negative. Here we have a chlorine atom, 17 protons, 17 electrons. Nonmetals tend to gain electrons, and we'll understand why that is later. But it's going to gain an electron. So now if it has 18 electrons, 18 negative charges, and only 17 positive charges, overall it has a -1 charge. So chlorine atom becomes an ion. The ions for the nonmetals, we do change their name a little bit. So the anions are named using the root of the atom name, and we change the suffix, the ending, to "ide." So chlorine becomes chloride. So I tend to think of the metals as being masculine and the nonmetals as being non-masculine or feminine. So when a man gets married, does he typically change his last name? No. Traditionally, when a woman gets married, does she change her last name? She does. When the nonmetals become ions, they change the ending of their name. So chlorine becomes chloride. Now, these charges form a pattern that we can see in the periodic table. Oh, and I forgot to talk about some things. We'll have to go back. I didn't talk about these different group names. The group names in the periodic table are not written on the periodic table, but the group numbers are. So on the periodic table, on the ones we have on the wall, they're just numbered straight across, 1, 2, 3, 4, all the way up to 18. On this one, you'll see I've put some Post-it notes up there. There's another system of numbering. It's the current American usage, and since we're currently in America, that's what we're going to use, because I like it. It makes more sense. And so we've got group 1A, 2A, and then this is 3A, 4A, 5A, 6A, 7A. And so the alkali metals are in group 1A, and they always form a +1 charge. The alkaline earth metals are in group 2A. They form a +2. The group 3A metals form a 3+ charge. And then in the nonmetals, group 6A doesn't have a name, like 3A doesn't have a name. But group 6A is -2. The halogens are in group 7A, -1. And the noble gases, what do we say about the noble gases? They don't form compounds very much. They don't form ions either, and so their charge is always going to be 0. Okay, so here we have a periodic table. So this is 1A, 2A, this is 3A, you get the idea. Sometimes they use Roman numerals. So let me talk about those groups that somehow the slides got screwed up and wasn't in there. The slides are my notes to remind me to tell you stuff, and when they get messed up, then I forget to tell you stuff. So this group over here, this first group, they have a special name. They're called the alkali metals. And this second group, group 2A, these are called the alkaline earth metals. Those names are similar, so try not to get them mixed up, earth metals. But you should know those names. Over here, group 7 has a special name. Those are called the halogens. And group 8 is the noble gases. We also talk about a couple of big sections on the periodic table. These sections that stick up, how should I do this? Let's go like this. So this part over here, see how that sticks up? And this part over here, those sections are called main group elements. Main group elements. And then these guys in here are called the transition metals. So the main group are the sections that stick up above, and the transition elements, this block in here looks like it kind of sunk down, like maybe there was a sinkhole or something and it sunk. The main group elements are the ones that are much more predictable. So we can predict what charges their ions are going to have. We can predict all kinds of stuff just from their position on the periodic table. And these guys, these transition elements, transition metals, they're going to form ions that have different charges. They are metals, and so they're going to form cations. But this is sort of a transition from one part of the main group to the other. So here, group 1A, these metals form +1 ions. Group 1, +1. Group 2, +2. Group 3, +3. Isn't that nice? 1, 2, 3, +1, +2, +3. Now these guys over here, this is group 7 and it's -1. And group 6 is -2. Like, oh, what's up with that? Well, there's two ways to remember that. One is to take the group number and subtract 8. So 7 minus 8 equals what? -1. Group 7, -1. If we take group number 6 minus 8, that equals -2. Right? So 6, these all form -2. So that's one way to remember that. The other way is to pretend this is a board game. And you're going to start with your piece over here on the right side and you're going to count backwards. Counting backwards is minus, right? So here is 0, -1, -2. So if you need to know what the charge on selenium is, you say, well, I'm going to start over here. This is 0, this is -1, this is -2. So there's two ways that you can remember those. Any questions?
What's that element below calcium?
What's the element below calcium? Strontium.
Oh, yeah.
Sr, strontium. Most of these I made you memorize, but some of them I didn't. I'm pretty sure that gallium and indium were not on the list, and we won't run into those very often. In group 3, for the metals, we'll mostly just see aluminum. Any other questions? So for these ions, when they have a charge, what we do is we indicate the charge as a superscript, and we put the magnitude of the charge first and then the sign. And that's different than what we do in math, isn't it? In math, you would say, x to the -2. You'd put the sign first. Well, we don't want this to look like math, because we do math too, but we want to distinguish this. And so for the ion charges, the number comes first and then the sign. Another difference is that in math, if you had x squared, for a positive number, you don't put the sign. Well, here we are going to put the sign. So we do include the plus. What we don't include is the number 1. So here again, we're leaving out the 1s. So lithium plus means lithium plus 1. We just don't write the 1. And over here, chlorine minus means chlorine with a -1 charge. So we put the sign and not the number 1. So here's an exercise. An ion with a 3+ charge contains 23 electrons. Which ion is it? So 23 electrons. The electrons have a -1 charge, right? So this is a charge of -23. And overall, this has to add up to +3. So we want to know how many protons, how many positive charges. We know we have 23 electrons, and overall there's a charge of +3. So it should be, well, if it's 20, let's try that. 20 minus 23 gives us -3. Okay, so we need it to be 26. 26 minus 23 will give us a +3 charge. Does that make sense? So +3 charge, all of these choices have +3. How do we know which element this is? 23 protons. Because 23 was the number of electrons. So we're not going to look for 23 protons, we're going to look for 26, right? And element 26 is iron. So this must be Fe3+. The number of protons tells us which element it is. In a question like this, they're not giving you the number of protons, they're giving you the electrons and the overall charge. Any questions? And some interesting expressions on people's faces.